Ladies and gentlemen, thank you very much that I got the possibility to contribute to the conference with this talk. Unfortunately, I cannot come in person, but I'm very honored that I can say a few words about climate services and the idea of climate services, so that this might be an interesting topic which you will further discuss during the course of the conferences. My title of the talk is Climate Services Through Partnerships, and I will give you a little bit of an IPCC messages as the outline. So on the next slide, you see that I will talk about IPCC headline messages. I will talk about adaptation, communication, and co-production, and I give you an outline and a facet at the end. Next slide, please. The IPCC, one of the IPCC messages is that there is a warming of the climate system which has been observed over the last decades, and this is very clear and has clearly been stated by IPCC, as you know. Next slide, please. One of the headline messages, which are also there from the summary for policymaker, is that I think I'm on the next slide already, if I see it correctly. Could you please go to the next slide? Thank you very much. So there are observed changes in many components of the climate system, as has been stated by IPCC. The atmosphere and the ocean have warmed, the amount of snow and ice has diminished, and the sea level has risen, of course. And what we all know is that the concentration of greenhouse gases in the atmosphere has increased. Next slide, please. How the future might look like is also presented in the IPCC report, for example, in different chapters, but also in the Atlas of Global and Regional Climate Projections. And I think here now is the evidence very clear from one side, from the observations, but also from the projections for future possible development of climates, that we are living in a changing climate. And this means that we have somehow to adjust to that climate, to mitigate as much as possible, of course, greenhouse gases, so that we can keep the warming limited. But we have to think a little bit about what has changed already and how can the society cope with this. Next slide, please. You also probably know already that there are very high resolution climate projections which are established within the Cortex framework, a WCRP framework, where also one of the focal areas is around the Central America. I'm giving you here a little bit of an overview of the region, for which very high regional climate change projections will be produced. They partly have been produced already. And what do I mean by very high? Very high is high horizontal resolution with a grid size of roughly 50 kilometers. If you compare this to the global climate model projections, you can hope for much more detailed information for the region. So before we can think about what climate services can do for society and help society to adjust and adapt to climatic changes, we have to look a little bit at what has been observed and what will be projected. In IPCC, and this is what you see on the next slide, please, is that the Working Group 2, the second part of the IPCC report, is looking at possible impacts of climatic changes, adaptation option, and of course the vulnerability of specific regions. On the next slide, we see the new concept for IPCC, Working Group 2. And I think this is of special interest because for the first time, the climatic changes have been have been determined in the way of a risk analysis. So I can't really see the slide, but I assume you see a slide where in the middle of the slide you see risk. And risk is determined by the vulnerability of a region, by the exposure, and by natural hazards, like extreme weather events, for example. And IPCC has put the climatic changes into this risk concept, in which also changes of the socioeconomic pathways, adaptation and mitigation actions are included, but where also the climatic changes, which you see on the left side of the slide, are included, the natural variability as well as the anthropogenic climatic change. So I think this is quite interesting because adaptation has a bit of a negative connotation. To adapt to something is often seen as something which you cannot avoid, but which you have to do. So you are forced to adapt to something, if you want or not. If you have a concept of risk and risk management, then the notation is a little bit different. We are all used to live with risks. We know about risk. We know sometimes how to manage the risk or to lower the risk. And I think to view climatic changes in the risk framework is very interesting. Next slide, please. Very important is the observation system and the monitoring in the back. So only from all the observations which have been gathered over the last decades, IPCC could evaluate and see in the literature that there are widespread observed impacts. So observing systems are important for hydrometeorological parameters, but also for the biosphere, for example. On the next slide, you see another region where observed impacts could be there. I think you could go to the next slide, please. This is for the oceans, and then please to the next slide. Of course, an increase of warming is also increasing the likelihood of severe and pervasive impacts. So when we later come to the role of climate services, then we will of course think about ways how society can cope with those impacts. And one very important impact in addition is on the next slide on the food production. There is, of course, under a high emission scenarios, under strong warmings, there's of course a high risk for a decrease in food productivity. And this, I think, is considered as a very high risk, which needs to be looked at, and attention has to be paid to this. So on the next slide, the positive message which is given by the Working Group 2 report is that society has measures and possibilities to reduce and manage those risks. And I would like to show you on the next slide one figure which comes, as in the others before, which comes out of Working Group 2 of the IPCC report. It is probably a little bit too small and you cannot see so many different things, but in the Working Group 2 on this figure, which is also, I think, in the summary for policymakers, are 3 key risks identified, and for each region, so for specific continents. And you see there 4 color bars which run in parallel, one below the other. They are for different times in the future. And the blue part is the risk. The entire length of those bars is the risk level, which goes from very low risk to very high risk. And the upper bar is for today, and the next is for the near future, and then for the long term under a 2-degree warming and for under a 4-degree warming. But this is not so important. What I would like to draw your attention to are the colors. If you look at the blue plus gray bar, the length, then you see the entire risk level with today's adaptation, so maybe no adaptation. If you then look at the gray part, then you see how much you can lower the risk if you are taking adaptation measures now or soon. So I think this is very important when it comes to Central and South America, for example, which is on the left bottom side. There are three key risks identified. One on reduction of water availability and increased floods and landslides. That's the upper one. Reduced food production and quality, and vector-borne diseases. So for all of them, you see next to the blue bars, you see a bit of the gray bar, and that's the amount of which we are able to reduce the risk if we are taking adaptation measures. And if we would do this, on the next slide, you see that we can live in a much more effective climate change adaptive world. And on the next slide, IPCC already give you an idea about the processes which are needed to start these adaptations. So you see there the scoping. This means from the left side, identification of risks and vulnerabilities, and establish decision-making criteria. There is an analysis cycle embedded where the risks have to be identified and assessed, and then evaluate the trade-offs, of course, and identify options. Then there's an implementation part where the decisions or the options which have been identified need to be implemented, and together with this, there's a monitoring needed to find out if the adaptation measure which we are implementing makes sense and really helps a lot. So this is all I wanted to say about IPCC, because it really sets the context for the services which are needed, and the services can be provided by climate services, which are trying to bridge the gap between the climate science and society and the users. So on the next slide, we see what we all need when we go from climate change to adaptation. So the adaptation to climate change is based on climate change information. We talked about this a little ago when I showed you from IPCC that observations show that the climate is changing. So here the importance of observational monitoring systems is stressed, because we need this information in order to know to what we have to adapt to. We need also knowledge of the climate impact. We have seen this for the sea ice, but also for the food. We talked about it. Then there is knowledge of climate risks needed, which is often referred to extreme weather events, but it could also be referred to long drought periods, or a change of let's say, tornadoes or hurricanes. The knowledge of the vulnerability is needed, and now with the knowledge of the vulnerability, we cross the border from the pure climate science to the more social science, because the vulnerability, of course, is also dependent on the financial situation of a dedicated region, for example. If we would have all this knowledge, we have to realize that there is a need to adapt. So the stakeholders of the region have to agree and to understand that there is a need for adaptation, and that this adaptation will bring new chances for them, that they are not only negative adaptation, but there are also new options for future development. Then the adaptation measures need to be developed and implemented. And for all of this, of course, we need a lot of money. And this, of course, is often a problem. On the next slide, this will be motivated a little bit more, so that adaptation to climate change is really not cheap. Think about conservation of a company or about the urban water management, the changes you need to do to the sewage system, for example, in cities, or construction of dikes. So it is very clear that these all cost a lot of money, and decision makers and engineers and other stakeholders need interest in this topic, and they must be sure that they can get the best available information on climate change as possible. So a large part of the role of climate scientists and climate services is communication. And I would like to talk a little bit about communication. Next slide, please. So there are different communities involved. Climate science, of course, is the very important part, delivering information to climate services. Then there are also practitioners who already work a lot with hydrometeorological data, for example. Let's think a little bit about the different roles of these communities. Next slide, please. Currently, the concept was a kind of a top-down concept. So emission scenarios have fed into global climate change simulations. They have been regionalized, and they have then produced regional climate change signals. So information about how the climate might change in a specific region. But this is not the full story. Next slide, please. In the entire process are many more disciplines involved than, I would say, just the climate science. So here you see the idea about the concept, about the role of climate services, bridging the gap between research on the left side and practice on the right side. So in research, for example, are many interdisciplinary groups. Climate science is one group there with a lot of expertise, but also impact analysis or risk assessment belong to the research part. On the practice side, we see all the sectors, or some of the sectors, which have to be considered and which we need to adapt to climate change. There's food, energy, public services, economy, health, water availability, urbanization. So the challenge which we face at the moment is that we have to start a transdisciplinary dialogue between the practitioners and the research communities, so that we can use the climate services as a kind of integration tool or bridge building institutions and bringing together these communities in order to start co-production of adaptation methods, resilience concepts, or vulnerability assessments. Because for these methods and this information, both sides are equally important. On the next slide, we see one example which comes from a EU project in southeastern part of Europe. Here, the question was about the future crop yield production. And for this, the question was, how might the crop yield production change in the future under climatic changes in that particular region? And here you see what goes into this assessment. On the upper left side, you see that the sensitivity of the data needs to be addressed, the sensitivity of the agricultural production. And here already meteorological measured data are input data, but also yield data and some metadata information. Then the exposure of the region to climatic changes has to be considered. And in the scenarios for future crop yield have to be calculated as an outcome of the physical impact. So here already you see that there are more interdisciplinary parts involved in assessments or in analysis of specific sectors in specific regions. And here this is just one example, and then there are many more of these. On the next slide, I would now like to start talking about the role of climate services. Climate services have been developed in the last, let's say, 5 to 8 years, and there are different models of climate service institutions. Partly an extension of meteorological services took part. They are, of course, very strong in meteorology and hydrology, and this is heavily geared by the global framework of climate services, which is a WMO initiative. The second type of climate service institutions are developments by university groups. Next slide, please. The university groups have the advantage that they are often multidisciplinary, and they can include social aspects in addition to the physical aspects, much easier and more natural than this has been done in the meteorological services. The cultural heritage is, of course, an academic, and there are some good examples for this in the US, but also in the UK with UK ZIP, which you probably know. Next slide, please. A third role model for climate services are, of course, expert groups which have developed in the private sector, consultant companies. They have strong interactions with customers in the private sector, partly with on the public domain too. They have a very good understanding of the economic aspects. So is the adaptation measure from an economic aspect also the one which would be chosen as the best one, the best for that purpose? They have limited experience mostly with climate research. And there's a fourth type on the next slide, please, which are new institutions which have been developed, like the one which I'm currently leading, the Climate Service Center in Hamburg in Germany. This is one, but there are others, one institution which has been initiated in the last couple of years, and the major idea was to have a very interdisciplinary group embedded in this new institution. Next slide, please. The Climate Service Center in Germany has been created in 2009, and the director until end of May this year was Guy Brasseur, whom you probably know. The funding came out of a high-tech strategy from the German federal government, from the Ministry of Research. And our mandate was to facilitate the transfer of state-of-the-art and easily accessible information between climate research and society. Now, during the last 5 years, we learned a lot. On the next slide, I start to go through 5 lessons learned, which I think are very important and should be considered for the future. From the discussion with the stakeholders in the last 5 years, it became very clear that climate services have to be credible. So a certain amount of trust has to be built up, and they should be objective and neutral. So neutrality is really key. This means that climate services should be independent from government, businesses, or political influences. Of course, they can make clear recommendations. But the neutrality and credibility is one of the objectives which we have been asked for by clients all the time. Next slide. The second lesson learned is that the service needs science the interface between science and the user has to be improved. And we are currently discussing the development of a translation layer between the different communities. There is the basic climate research, and then there are the stakeholders, the users who are asking for the climate change information. But until now, there is no applied climate science. And this is something which needs to be developed. It is an area where the information from the users of what they really need, which kind of product they need, what kind of information, timescales, variables, guidance, what they need, goes to the science side, and will then be researched, and in the translation layer, in the applied climate science, the contact between the two groups can be established. On the next slide, we see the third lesson, which we consider of importance, and that's that the user's needs are very client-specific and case-specific. There is no one-size-fits-all product. This, of course, makes it very complicated, but it is clear that regional features and specific circumstances in the individual regions have to be considered. So this development takes time, of course, but it really is an interest and a large challenge because it leads to a close cooperation between the customers and the scientists. And this is a very, very exciting field. Next slide, please. The customers sometimes do not know which service and products fit to their requirements. This became also very clear. And here now, the message from us from the last years is that a dialogue with the customers has to be established. This takes some time, and it often starts in a small meeting, on a conference maybe. It starts with a conversation, then it develops often into a confidence building phase with some first contracts, and then it goes into a long-term partnership. Next slide, please. It is also important that the national conditions differ from one country to another. I think this is very important because it makes clear that we cannot just establish one worldwide climate service and then think everything is fine. It is important that the national and subnational requirements are taken into account because adaptation is a local phenomenon. And the local characteristics, the experts from the region, the expertise from the region is of great importance and has to be taken into account. So climate services have to develop on a national and subnational level. Next slide. After 5 years of experience, we are now institutionalized as the Climate Service Center in one of the research associations in Germany, the Helmholtz Association, and as we are institutionalized as a national institute. We have an interdisciplinary team of about 40 staff members, and we work with very strong partnerships. We work with networks in the scientific community as well as in the stakeholder community. Next slide, please. We have the target group. Our target group are decision makers, and we focus on the water sector, the energy sector, and ecosystems first. We have 3 main areas of work: the networking, which I already said. We build networks in science and on the user side, and we bring people together. Sometimes we just bring them together and then they work on their own, they do cooperation, and we step back and go to the next network. We have a strong part of capacity development. We are developing schools, materials for engineers, for politicians, for companies. And we have a part where we develop prototype products and services. And I will talk about this a bit more now. Next slide. So for us, the communication formats are, of course, manifold. So there are personal meetings, internet information, but most important is the development in cooperation with the user. Next slide. In this, we developed reports and documents, for example, an analysis of the demand of climate change information in the agriculture sector and in the water management sector. This is a typical example where we first ask the stakeholders in that sectors, what do you actually need? How are you affected by climatic changes? Next slide. When we talk to the consultancies, then we found out that they use very different statistical methods. So one part of the role of climate services is also to provide the information about the best practices or statistical methods for the analysis of climatic data. Can be observed data, can be simulated data. So we collected this and published it in a report. It is very simple, but these are helpful documents. Next slide, please. What became very obvious was that the different disciplines talk different languages. So we created a comparative lexicon which is regularly updated, where we document and define the terms which are used in the different disciplines. Next slide. Another example is methods and tool for the climate risk management. So besides providing climate change information from, let's say, global and regional climate models, the climate services also have the role to help to work with these data, as I just said, for the statistics, for example, but also beyond this with methods and tools to help to analyze the climatic risks and to start the first action towards adaptation. Next slide. Another typical prototype product are climate change hotspot maps, which we have developed together with the German Development Bank, the KfW. They have asked us about robust information for global climatic changes in order to find out which regions are most vulnerable and in which regions their development activities needs to be strengthened. Next slide. Another very successful product which we have also developed together with the KfW, the German Development Bank, and actually these are fact sheets, climate fact sheets. They are now used by many other banks too. These are 6 to 8 pages information about today's and future climate facts for a specific region. Here you see an example from Mexico, where we have collected the information of the today's climate, which is given in a short paragraph. And then we have analyzed all available global and regional climate change simulations from all climate change scenarios about their robustness and their changes in, let's say, temperature or in drought days or in heavy precipitation. In addition to this summary, we also give an expert judgment. This was very important for the customer, the bank, because they wanted to know if there is low or high confidence, or if there is if the strength of the climate change signal is strong or not so strong. Next slide, please. We also give the next slide, please. Thank you. We also give a kind of a help how to read this information. So what actually do the different colors mean, what the bandwidth is, and how to work with this. Because this information is used by the project managers of the KfW when they first look as a project which they would probably, an infrastructure project in a region which they are asked to facilitate, so that they get an idea if this infrastructure project might be somehow harmed by climatic changes. Next slide, please. You can see here that there are about 40 climate fact sheets available. Currently, they are built on the AR4 data, but in the future, they will now be updated. And then I'm almost at the end of my talk, but the next prototype, next slide, please, is of a completely different nature. It is an adaptation toolkit for a city where we support cities in increasing their resilience to climate change. And here mitigation and adaptation is taken into account. This has also been initiated by one of our customers, a city close to the Baltic Sea. And here it consists of different flexible tools, which it's kind of a modular design, which can then be tailored towards the needs of a specific city. It has modules in it about participatory processes, but also about the city climate, about the possibility how to get financing for climate change adaptation, but also information about the urban water system, for example, how that could be adapted to climatic changes. So I think these are quite interesting examples which can be transferred, of course, to the different regions and need to be changed and adapted to the regional characteristic. On the next slide, we see again, and we are coming back now to the different communities. So here we see again how important the networking in science is, and that we have to account for the diverse group of users. So on the y-axis, we see that the climate change, of course, is a global phenomenon, but it has regional and local parts in it. On the x-axis, we go from climate modeling to the impact assessment and to the adaptation policy. So we see that the communities, let's say the Earth system modelers, this statistical dynamical downscaling, then it goes to the impact researchers from left to the right, it goes to the practitioners and to the adaptation policymakers. This all needs to be linked and bridged, and climate services play a very strong role in bringing these communities together, and regional climate modeling, of course, can help linking this with the climate services. On the next slide, I now finally come to my facet and to an outlook. Can you go to the next slide, please? So I think it is very clear that there are many different communities involved in the climate change issue. We have to first define the roles of the involved communities, of what is the role of the users, the practitioners, the science, and all the other groups involved. Then I think it is important to define the linkages and the interfaces between the communities and the gaps. And then we can start to develop products and close the gaps jointly with activities in the translation layer. So there, the real work between climate science, the different disciplines in climate science, and the practitioner starts. So we need the networking in order to go towards a worldwide market for climate services. Thank you very much for your attention. Bye-bye.